Hello everyone, in this video let's discuss how easily we can solve the series and parallel resistance problem in electronics. So let's discuss two problems so that you will be perfect enough to solve any problem related to this topic. So the first problem is find the equivalent resistance between A and B. So to solve the problems related to series and parallel, we just need two formulas. The first one is when the resistors will be in the series connection. So when the resistors will be in the series connection, so you just add all the resistances R1 plus R2 plus like that up to Rn. Rn means how many number of resistors are given in the series, you will add all of them directly. Now if we see the condition of the parallel resistance, so in this condition what we will do, we will reciprocate the resistance value and then add. So if you see here 1 by R1 plus 1 by R2 plus up to 1 by Rn. But if you see the value is reciprocated, if you want to find the total resistance, it will be in the form of 1 by RT because you have inverted the values of the resistance. To find the total current R, so at the final stage, you must reciprocate the total value. After addition, what you will get, if you reciprocate, you will get the final equivalent resistance in the parallel resistance circuit. So, there is a short trick for two resistance. When you are calculating the equivalent resistance of two resistance which are in parallel, there is a short trick. That is R1 into R2 divided by R1 plus R2. If I consider R1 and R2 as the two different resistances or the same resistance value which are in parallel to each other, then I can find the equivalent resistance using R1 into R2 divided by R1 plus R2. So now let's solve this problem, you will understand easily. If you see here, 16 ohm resistance and 8 ohm resistance are parallel to each other, and 10 ohm resistance and 10 ohm resistance are series to each other. Here they are parallel to each other, here they are series to each other. So if you want to find the value when two resistances are in series, what you will be doing? You will be just adding their resistance value. So 10 plus 10 will be 20. 20 will be the equivalent, and here 20 I am having. So this is 20 ohm resistance. Next, here 6 ohm resistance is there. It will be as it is in this step. Next, you are finding out the equivalent resistance between the 16 ohm resistance and 8 ohm resistance which are parallel to each other. Here I am having two resistors itself, so I can use this formula, that is short trick. What is the short trick? R1. Let me consider 16 as R1 and 8 as R2. 16 into 8 divided by 16 plus 8. So what will be the value? 16 into 8 will be 128 divided by 16 plus 8 will be 24. So 128 divided by 24 will be 5.33. So this is the equivalent resistance of these two parallel resistances. So I can write 5.33 ohm, which is in between A and B. Now if you see this 20 ohm resistance and this 20 ohm resistance, both are parallel to each other. So when the two resistance are parallel to each other, you can use this formula. So 20 into 20, 20 into 20 divided by 20 plus 20. 20 into 20 will be 400 divided by 20 plus 20 will be 40. 0 0 cancel, 4 ones are 4 tens are. So 10 is my equivalent resistance here. 10 ohm. Next, if you see here 10 ohm resistance and 6 ohm resistance, both are in series connection. When they are in series connection, you will just add their resistance value. If you add 10 plus 6, it will be 16. 10 plus 6 will be 16. Now 16 ohm resistance and 5.33 ohm resistance are in series, are in parallel to each other. When they are parallel to each other, since I am having only two resistances, I will be using this formula, that is 16 into 5.33 divided by 16 plus 5.33. So what will be the value? 16 into 5.33 will be 85.28 divided by 16 plus 5.33. It will be 21.33. If you just divide them, 85.28 divided by 21.33, it will be 3.99. So you can equate it to 4 ohm resistance. So the equivalent resistance between A and B is 4 ohm. So you can conclude like this. So let's solve the another problem. You will get it much easierly. Now if you see, this is the second question. Find the equivalent resistance across the source. So what is the source here? Voltage source is there. We must find the voltage across that source. Now let's find. If you see here, 1 ohm resistance and 1 ohm resistance are in series. Series means you will just add them. Next, 3 ohm resistance and 3 ohm resistance are parallel to each other. 2 ohm resistance and this 2 ohm resistance are parallel to each other. So how this is parallel means you can rewrite this like this. So from here only you can connect here 2 ohm resistance. If you see, both these 2 ohm resistance and 2 ohm resistance are parallel to each other. Now let's find the equivalent circuit. Now, this 1 ohm resistance will remain as it is, 4 ohm resistance will remain as it is. 1 ohm resistance and 1 ohm resistance which are in series will add up together. 1 plus 1 will be 2 ohm resistance, which is the equivalent resistance. Now, 3 ohm resistance, 3 ohm resistance are parallel to each other. I am having 2 resistance, so I can use this formula. 3 into 3 divided by 3 plus 3. 3 3s are 9 divided by 3 plus 3 will be 6. So 3 3s are 9, 3 2s are 6. 3 divided by 2 will be 1.5. So this is 1.5 ohm. Next here, 2 ohm resistance, 2 ohm resistance. 2 into 2 divided by 2 plus 2. 2 2s are 4 plus 2 plus 2 will be 4. So 4 1s are 4. So 1 ohm resistance is the equivalent. Now if you see 2 ohm resistance, 1 ohm resistance, they are in series. Series means just add together. So 2 plus 1 will be 3 ohm resistance. 4 ohm resistance and 3 ohm resistance are parallel to each other. When two resistances are parallel to each other, I can use this formula. 4 into 3 divided by 4 plus 3. 4 3s are 12 divided by 4 plus 3 is 7. 12 divided by 7 means 1.714. So we got the equivalent resistance of these two parallel resistances, that is 1.714 ohm. Now this 1 ohm, 1.714 ohm and 1.5 ohm are in series. So you can add directly. 1 ohm plus 1.714 ohm means 2.714 plus 1.5. 2.714 divided plus 1.5 will be 1 and 4 will remain as it is. 5 plus 7 will be 12. 2 1 carry. 2 plus 2 will be 4. 4.214. So 4.214 will be the equivalent resistance which will be across the given voltage source. So they have told to find the equivalent resistance across the source. Source is voltage. We found out the equivalent resistance across the source, that is 4.214 ohm resistance. So hope you understood how to solve the problems related to this topic, that is regarding the series and parallel resistance. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you like the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.